When you add a solute to a solvent, you make a solution. So a solute is the particles that are dissolving. If the solute and solvent are in the same phase, it's the one that we have in a lesser quantity, while the solvent does the dissolving. So for example, when you pour salt into water, salt is the solute and water is the solvent. The second part, if they're in the same phase, the one that's the lesser amount is the solute, means if I had 5 milliliters of water and 100 milliliters of alcohol, water would be my solute because I have a lesser amount of it, but they're both liquids. But if you have a solid and a liquid, the solid will always be the solute as it will dissolve in the solution or the liquid. We can express concentration one of two ways. Qualitatively, which doesn't have a number involved, so we can say something is very dilute or something is very concentrated, but that doesn't give us a whole lot of information because those definitions differ from one person to another. For example, if you were making Kool-Aid and you add a lot of sugar and powder to your solution or to your Kool-Aid, and you drink it and you're like, that's just right. And then one of your friends drinks it and they're like, man, that's really concentrated. You added a lot of sugar to this, didn't you? And then someone else may drink it and be like, man, this needs more powder, more sugar. So that person may think it's dilute. So if we put a number attached to it, then it's going to mean the same thing to everyone. So in this section, we're talking about molarity, which is our main way of expressing concentration. So molarity is the number of moles of solute per liter of solution. And it's represented with a capital M. So make sure that you write down the equation. Molarity equals moles of solute over liters of solution. Sometimes they'll say that you have a 1.25 molar solution. So let's say we had a 1.25 molar solution of sodium chloride. What that means is I have 1.25 moles of sodium chloride for every 1 liter of solution. You can see in our comic down here that if we had 1 liter, then that means we would have 3 moles of solute in my 1 liter. Obviously, it's not real moles, but... And another joke over here, we have a 5 molar solution because we have 5 molars in there. Nice dentistry joke for you. All right, so looking at the actual problems that you would have. It says how many grams of sodium hydroxide must be used to make 500 milliliters of a 2.5 molar solution. So when you see 2.5 capital M, you should think that that's 2.5 moles of my solute. My solute is sodium hydroxide. Well, sodium is a +1, hydroxide is a -1, so we have 2.5 moles of sodium hydroxide for every 1 liter. So we're going to set these up using dimensional analysis like we've been using all year. So we're going to start with the number 500 milliliters. I'm trying to get my answer in just 1 unit, which is grams, so I'm only going to start with the 500 milliliters. This molarity is a conversion factor. I'm going to have to get my milliliters to liters. So milliliters to liters, and there's 1,000 milliliters in a liter. My milliliters cancel. I know liters have to go on the bottom. Now that I have liters, I can use my conversion factor of 2.5 moles for every 1 liter. If I was looking for moles, I would be done, but I want grams. So one more step. 1 mole of sodium hydroxide equals so many grams. Just like we've been doing, we can convert grams to moles by using the molar mass. From the periodic table, I get 40 grams is 1 mole. Multiplying and dividing, we have 2 sig figs, so we should just get 50 with a decimal. So 50 grams of sodium hydroxide will be needed to make a 2.5 molar solution. All right, let's look at one more problem. In this case, they say that we have 35.8 grams of lithium hydroxide. We're going to dissolve that in enough water to make 750 milliliters, and they want to know the molar concentration. So molar concentration is moles per liter. We, in this case, want 2 units as our final answer. So we don't have moles, but we do know grams. And we don't have liters, but we do have milliliters. So this is what we're trying to get our final answer in. So we're going to have grams over milliliters. My grams, I need a formula. It's lithium hydroxide, so LiOH. I need to convert my top unit to moles, and I need to convert my bottom unit to liters. So milliliters to liters. There's 1,000 milliliters in a liter. I have my bottom unit. Now I need to convert my grams to moles. Well, I know 1 mole is equal to so many grams. And I can get those grams from the periodic table. And I get 23.95. Grams cancel, leaving me with moles. So I have moles over liters, which is molarity. So after I multiply and divide, I get my answer. Make sure that you're plugging it into the calculator right now and that you get 1.99. And that's moles per liter. You also could say 1.99 capital M, because molarity and moles per liter are the same thing. Go ahead and pause the video and try this one on your own. Restart when you have an answer. For this one, you should have gotten E. If you got C, then you didn't read the question. It said how many milliliters. C is how many liters you have. So if you didn't get E, let's see how we can get E. So they gave you grams, and we're looking for milliliters. They also told you your molarity. When you see your molarity, make sure that you're writing out what that means. That means I have 0.50 moles of my solute, which is sodium chloride, for every 1 liter. So it's always going to be moles per 1 liter. I'm going to start with grams because, again, molarity is a conversion factor. So I have 40 grams of sodium chloride. I cannot use the conversion factor yet because I have to get it to moles. So I convert my grams to moles. 1 mole is equal to 58.44 grams. So grams cancel, and I'm at moles. So moles goes on bottom and liters on top. I plug my conversion factor in. 0.5 goes with moles, and 1 goes with liters, according to my conversion factor. So moles cancel, and I'm at liters. But again, that's why you have to read carefully. It says milliliters. So liters to milliliters. 1 liter is 1,000 milliliters. Multiplying and dividing, you should get this number, which then rounds to 1,400 milliliters in 2 sig figs.